And again, really appreciate y'all for coming. Timo or Duncan, if you wouldn't mind sharing your slides real quick, I think we can go to our title screen. But we appreciate your time this morning. Welcome to our next live demonstration. Today's topic is Jumpstart your AI development on MongoDB Atlas Vector Search and SuperDuperDB. And I'm really excited for this one because we're trying something different, not only with Slido, but also with our presenters. Today we have two guest speakers from SuperDuperDB. Duncan Blythe is a founder and CTO from SuperDuperDB, and Timo Hageno is the co-founder and CEO of SuperDuperDB. They will be leading today's live demonstration and showing you how you can really kick off your AI development journey with both vector search and SuperDuperDB. And in the background, we also have Jeff Schmitz, who's your advisory solutions architect. He is monitoring the chat and Q&A in case you have any questions during the webinar. And we did reserve about 10 minutes towards the end of the webinar as well. So please feel free to keep your questions coming. If we don't get to them, then we'll address them at the end of the webinar. And yes, this webinar will be recorded. The last thing I'll mention real quick before I hand it over to the speakers, this is part of a series on SuperDuperDB and also on AI development that we're currently running. In about 2 weeks, for anyone interested from this call, we're going to host a more intimate setting, a 30 attendee cap workshop where experts will sit down with you, give you a provisioned instance to run Atlas Vector Search and SuperDuperDB and let you kind of play around with the materials we talk about today. Just keep an eye on that on your calendar in the coming weeks.
Yeah, and make sure to sign up for that quickly if you want to attend, because there is limited spots for that, and that will fill up very quickly.
More information will be shared after the webinar. With that, I will hand it over to Duncan and Timo.
Yeah, hi guys. Very excited to be here. We heard that some of you already, try out to build something with SuperDuperDB, which is amazing. But I will quickly introduce myself and then also SuperDuperDB. Actually, we have kind of an agenda set up. What I said, we're going to present the concept, and then actually we jump right into the first notebook, into the first use case we've already implemented, which is video search. Then we go back to explain a bit deeper the concept of SuperDuperDB, and then actually we're going to together look into how to set up a RAG chatbot application using SuperDuperDB on MongoDB Atlas. And yeah, that's what you can expect. So I'm Timo. I'm one of the two founders and CEO of SuperDuperDB, and Duncan is my co-founder, CTO. And we decided to build SuperDuperDB because we've encountered many different teams, companies, and especially their challenges when it comes to actually leveraging what's coming out of open source and what's now publicly available via APIs like OpenAI. There's so much of just groundbreaking technology, but it's very hard for people to actually make use of it and kind of leverage these technologies for their products and services, hobby projects, whatsoever. And yeah, there is a good reason for that. Duncan, maybe you can also quickly introduce to that, but then I would explain what I meant.
Yeah, hi, I'm Duncan. I used to do AI research, and for the last 5 years I've been in the industry, started in e-commerce. Then we founded an AI innovation lab, and the fruits of this journey were SuperDuperDB.
Exactly. So before we start, I want to quickly show you what SuperDuperDB is about. So it's an open source project, right, which you can access on GitHub. So this is the link, Jeff. I think you just shared it. So it's open source, Apache 2 license, the whole thing. And yeah, SuperDuperDB, what it does, it brings AI to your favorite database. And this is in contrast to classical solutions in the space of MLOps. And MLOps is basically the term of bringing machine learning models to production and to actually create value. So basically, when you leave this experimentation notebook stage, how you can actually apply AI. And yeah, as the name suggests, we're not another database. So SuperDuperDB is not another database. It's a framework that transforms, that super dupers your existing favorite database into an AI powerhouse. And that exactly enables even individual developers to build and manage AI applications very easily without actually needing to basically take your data out of your database, ingest them into complex and fragile MLOps pipelines, and specialized vector databases, because we kind of bring all these functionalities to the database and allowing developers to integrate them with a very simple Python interface. So the whole thing is, today it's Python. Later on, we're going to introduce probably other, for example, JavaScript SDKs for developers to work with. But yeah, instead of having to adopt many technologies, introduce a bunch of solutions into your stack, you can basically enjoy a single deployment of all your AI, which is scalable, taking care of everything, model training, model fine-tuning, the inference in real time. And that's it. So you can integrate models from PyTorch, any PyTorch model, scikit-learn. You can take models from Hugging Face. And in the same fashion, with simple Python commands, you can integrate AI APIs, whether it's OpenAI, Cohere, Anthropic, Vertex. So basically, these are the inbuilt integrations we have. But of course, we're going to extend this in the future. And you're going to see here, we already have a bunch of exciting, well, it's for you to decide, use cases which we implemented. And you can access them very easily here through a service we set up, which is a Jupyter cloud notebook. So you don't have to install anything locally. You can basically just launch it, and then you can play around with the notebooks and look at the different use cases. And actually, that's what we're going to do now. So this is a text-to-video search use case. It's where we take a video, or a bunch of videos. In this case, in the notebook, it's just one video. And then we gonna basically have a couple of simple steps to allow you to allow the user to use natural language to actually search through the video and find the relevant sections in the video which match your search input, your query. And exactly, this is how it looks like. I hope it launched, by the way. Yeah, so you can see here on the left the couple of use cases, and this is the notebook, so you can jump right in. Don't be confused. The session time is limited to 30 minutes, and then you're going to be kicked out to release resources. We're currently working on a solution where you basically restart a session, and then you can log in and out and continue your workflow. Right. So, Duncan, I would like to hand over to you, and you can then run us through the notebook. Maybe as you basically get everything set up, if you have any questions, you can always interrupt. I don't know if you can unmute yourself, but at least in the chat, we try to pick it up immediately, as long as it's somewhat connected to what we're talking about. Otherwise, we're going to answer the questions in the Q&A. And also, what I wanted to mention, or anyway, I'm going to mention later again, we have a community Slack. You can join there. You can ask questions. You can reach out to me directly. It's timo@superduperdb.com. Same for Duncan, Duncan. And actually, we are interested in partnering with you. So when you try to build things and you encounter any problems or you wish support, you can always reach out to us. We're actually also very keen to identify design partnership projects where we actually actively support you guys in building cool products and use cases using SuperDuperDB and MongoDB Atlas. So anytime we're available and happy to engage.
Can you hear me?
Yes.
Okay, so Timo mentioned briefly. So initially, I'm just gonna tease with a demonstration of how far you can go with this. It's a search use case leveraging Atlas vector search here. You can see my index here, and I've set it up in this notebook in a series of steps, which for vector search in particular tend to be similar. So if you want to adapt this to your use case, you just need to make a few changes, and then we'll explain a bit more what's going on. and go through a questioning the docs, so RAG use case. But initially, I'll just show you, as a teaser, what's possible here. And I think it was clear from the README, SuperDuperDB is about more than just vector search, but vector search is one very exciting thing you can do with SuperDuperDB in combination with MongoDB Atlas vector search. So what I've done here is I've followed a stereotype series of steps. So initializing SuperDuperDB with your MongoDB connection, adding some data, in this case, videos, setting up some models. So these are sort of the workhorses of AI, and configuring the models to listen for incoming data, confirming that this is working, setting up additional models. In this case, multiple models work together to perform video search, and configuring those models to become a search index, essentially. Exactly, and you can see the video that we're demonstrating on is just a video of various animals. You could take anything, and the outcome is that once I've performed these steps, I can just enter a phrase like monkeys playing, for instance, and a search is executed here with this command. I'll go through that later, what it actually means. But basically, I'm searching through the video with text, and with the result, I'm able to jump directly to that scene in the video. And you could put multiple videos here, so this isn't limited to that case of having one video. So even setting up video search is quite easy. Yeah, so maybe Timo, you continue with the explanatory content.
Yes, for sure. Exactly. As Duncan mentioned, this is just an example, right? With SuperDuperDB, you can enable multimodal vector search very easily, right? And of course, this could be capturing of I don't know, moving cars, and you can access damages. It can be anything, literally. All right, let me quickly reshare my screen. So we try to keep the slides minimal. It's basically just two advertorial slides here, and then we're going to jump right to the concept. So exactly what Duncan already mentioned, it's really not just about vector search and Gen AI, which is of course the latest and the hottest stuff everybody is looking for, but you can of course also just take standard AI models and use cases like classification, segmentation, which you can implement with just a couple of easy Python commands. And you can at the same time implement highly custom AI use cases using specialized models that you build and trained in-house. And yeah, what I mentioned before, it's instead of having like different domains to work together, different roles, if you're data science people, MLOps people, cloud infrastructure people, actually for managing and working with SuperDuperDB, you just need Python. Right, and then the great part is the data. The data is everything, right? Every AI is built on data. It remains where it is in its origin, instead of requiring people to duplicate the data and move it all over the place, ingest them into additional specialized databases just for single use cases. And it's a single scalable deployment instead of having multiple deployments, partially duplicated, sorry, excuse my German. And then, instead of having hundreds of lines of codes in different environments and notebooks, it's really just, it comes down to simple Python commands and just a few of them. So most of you have an understanding of vector search. Quickly, I'm going to touch on the high-level concept. What vector search does, it relies on vectors, obviously, and vectors are basically large numbers which can then be processed mathematically. And what you do is basically you take AI models, transformer models, to translate the meaning of something into these vectors, right? And you can do that for images, for text, for audio. Essentially, you can do it for any type of data, as long as you have the right model to actually perform this translation step. And once you have translated your objects into vectors, they kind of appear in a so-called vector space. And here on this, very simplified image, you're going to see a vector space which is three-dimensional, and then you're going to see a lot of dots. One dot is one object. You have basically one. Let's say these are images, but vectors, they have much more dimensions. They can be super high. So we see here they can be like, let's say 300. But what you're going to see that similar objects, they are basically close to each other because the vectors, the large numbers, they are similar or more similar. So you see like the cat is more close to a dog than it is to a chicken, and it's way further apart to a banana, right? And now when you look for something, this allows you to search much more efficiently and flexibly, because previous search solutions, which are keyword based, you don't have the exact matching keyword in your data, you won't find anything, right? And now you can basically use natural language as much as different search inputs. But for example, now when I search for kitten, although I don't have a kitten in my data set, I'm basically going to find objects which are very similar. For example, when I search for Cisco, I'm going to see Google basically as a letter which is most likely closer than for example, banana. And how does vector search work? So we see on the left, this is the same image we've seen before. So what you're going to do, you transform your data into vectors, into vector representations, also so-called vector embeddings. And then you do the same for your query, right? Whether this is natural text, on image, on combinations, or you could use hybrid queries using your image in text, for example, or you use an audio file, it doesn't matter. You do the same step. You also create a vector representation, and then you send this to MongoDB Atlas, and then in MongoDB Atlas, these vectors will be compared, and then you retrieve the results which are relevant to my query. And you can, of course, they can define how many objects you want to retrieve and so on, but these are all configurations. But now you basically have relevant information which kind of matches my what I want to find. So I can search by meaning. Are there any questions? Because I don't have an overview of the chat. Right. Otherwise, we're gonna quickly touch on why SuperDuperDB is now making MongoDB Atlas super duper, or is in generally super duper. So you install SuperDuperDB on your MongoDB Atlas, and then in SuperDuperDB you can, as I mentioned, with simple Python commands, initialize AI models, right? And these AI models, this vectorization step is done by simply by AI models. So you can, for example, connect OpenAI with their embedding service to generate these vectors, or you can self-host your own models in the same fashion, both as one Python command each. And then what happens? SuperDuperDB will retrieve the documents, and then will take care of the inference. And inference is the computation of outputs. So basically, you pass on an image to an embedding service or model, and then the model will return an output, which is a vector embedding, which is then stored back into MongoDB Atlas, and then it is accessible to Atlas Vector Search. And this is the whole concept. This is actually not a simple process, but now with SuperDuperDB, it is super easy. And this is what a RAG application looks like. So retrieval augmented generation, that's what RAG is. And it's a concept that you use when working with a large language model. So the problem is, as we know, ChatGPT, there's a cutoff in the information it was trained on. I think it was 21. I don't know exactly, but the problem is there's no actual information, right? So and also when there's changing information, or just information which wasn't existing, there's a high chance that you're going to retrieve a bad answer from GPT, because it simply doesn't know, it doesn't have the information. So what you do to overcome this, and also to avoid hallucinations and so on, is you feed the large language model with context information in the prompt, right? So you basically say, you kind of construct a prompt with the context, with the information I'm providing you in the following. Please give me an answer. So basically, on the fly, you educate your large language model, right? And there's many upsides, what I previously mentioned, also performance gains. You could use smaller specialized models and basically just feed the context which is relevant to your specific query, right? And this whole concept is kind of still the hottest application in AI, and it will remain that for at least for the next year. So it's actually just a couple of steps, but quite hard to set up. So the moment when you have this inference process, so when a user asks a question, you first need to embed the query, which is always the first step. So you need to send it to some embedding service, and then you're going to send the query embedding to your Atlas database, where it's then compared with the data which is contained in Atlas. So let's say, well, this is what the example we are showing you now. For example, we built an AI chatbot to ask questions about technical documentation. So what you do is you ingest your technical documentation into Atlas, then you create vector embeddings for it. And then now when a user asks a question, you're able to also generate an embedding for this particular query. And then you compare the vector of that query with the information you have available in your database. Right? And again, this could be anything. In this case, it's technical documentation. It could be images, it could be audio files, it could be time series data. It could be, again, anything, right? And now what happens after you compare the query with the information you have in your database, you basically take all of the information which seem relevant to the answer. And of course, you can configure how tight that should be, the relevant score. And then you take whatever you decide to be relevant. And then, and this is step 3, you basically feed it in the prompt to the large language model. And then what happens? The large language model, GPT, will return the best possible answer, which is way better than if you would had asked GPT directly. In many cases, it simply would not return any reasonable answer at all. All right. So how does that look, right? The application we are going to look at now, just quickly how it looks. So it's actually an application we implemented, not just for the use case itself, but just to convey how quickly and how easily and nicely you can actually build end-to-end AI applications on Atlas with SuperDuperDB. So we took inspiration of Mandible.ai. So it's a startup which joined Y Combinator this year. And the only product is this chat here. And you're going to see our front end. So this is implemented on the farm stack. We use FastAPI, MongoDB, and React. It's actually deployed on fly.io, but it doesn't matter. It doesn't matter. You can deploy it anywhere. But you're going to see it looks very similar. And you know, if you follow this page, it's qtd.superduperdb.com. There's also some technical documentation. It's of course also open source. You can re-implement it yourself. Or you can actually reach out to us and tell us, look, we have this data should be textual because it's a text chatbot, and then we're happy to implement it for you. So we also implemented, just to illustrate this, the LangChain documentation, Hugging Face documentation, and you can try it out here, and you can actually also use it in action on our docs. And I'm going to quickly show, you know, basically you can. What is vector search? So when I do this query now and I hit the enter button, what is vector search? This query, search input will be vector embedded. So we're going to generate a vector. Then we send it to MongoDB, compare it with the technical documentation or the vector embeddings of the technical documentation contained in our database cluster. And then it will return the relevant information, put it into a prompt. In this case, we use OpenAI GPT as a large language model. And exactly it does what I mentioned before. We basically say, look, with the information provided, come up with an answer. If you're not sure, don't return an answer at all, because we really want to avoid that kind of GPT is providing you a misleading answer. That being said, we have a big release coming up on the 15th of November, where we're going to have a big overhaul of the docs. So in case the chatbot is not performing super accurately on some questions, that's basically because there's an information lag in the documentation, right? Because there's basically, we haven't had time to document everything in the lowest on the lowest level in detail. But anyway, it's a super powerful application, and you can set this up, and we're going to see that now in the notebook, actually in less than an hour. And this is kind of a game changer, because if you would have done that with standard MLOps tools and infrastructure and pipelines, it's a nightmare, right? You need exactly when you remember the table in the presentation, you need different expertises, different domains, different environments, different languages, all of that together. And with SuperDuperDB, it's really just database queries and simple Python commands. And yeah, we're gonna basically look into how that actually works in the notebook now, Duncan. But maybe again, before you start, are there any questions?
There actually were a lot of questions. Duncan was filling them all. But in the Q&A box, there's a few questions we didn't answer. Can SuperDuperDB be used with MongoDB on premise?
We did answer that. Yes, absolutely.
Great.
Exactly.
Next question. Oh.
Yeah, so maybe just to add to this, we are currently finalizing a Kubernetes deployment, which then allows you to deploy SuperDuperDB anywhere, on-prem, on your private cloud, or on public clouds. So yes, you can. That's a good part, because it's truly open source. Core functionality will always remain open source. It is a community product. Of course, we're gonna build a managed service at some point, but you can always fully own the IP, and this is like you don't potentially enable these data security use cases and so on.
Yeah, and also, Danny, make note that they could use search on premise now using the Atlas CLI, and also vector search using the Atlas CLI now on prem.
Awesome. The next question, real quick. How much processor capacity is required by the transformer and the vector processing to generate answers to queries?
That would depend on which model you use. So if you host your own model, there are models of different sizes, and some of them are quite compact, of slightly lower quality. And then, of course, you have larger models like Llama 2, which you need your own cluster essentially to host with multiple cores and GPUs. And then there are models which are hosted behind APIs, which is probably for Cisco not an option, but still those of course require almost no compute because the compute's going on a remote server.
Thank you.
Okay, so then shall we move on to the notebook, Timo?
Most certainly.
Yeah. So I'm going to now show how to set up the app that Timo described, the retrieval augmented generative app. So questioning our technical documentation with SuperDuperDB. And this time I'm going to go much slower and explain the steps and also show you what's going on in Atlas on another tab here. So I've already got the video example installed here with a search index, a vector search index. So I'll show you how that would go, but on a different example, so you can see it again in a different context. So the first step is to initialize your connection to SuperDuperDB. So in this step here, I've imported the right functionality, and I've passed my URI of my cluster, which is, you can't see it here, but it's an environment variable, and connected to SuperDuperDB, which itself connects to MongoDB. So that gives us this connection here, which actually contains various things. So it contains the MongoDB connection, it contains information about our models, and it contains metadata. Okay, so that's the sort of main object with which you'll be working with and communicating with your MongoDB when you're installing functionality with SuperDuperDB. All right, so now I'm going to load some data. I've got the technical documentation in my local directory. And you can see this is the first paragraph of our documentation. So these are markdown files. And I've basically, with this one block here, I've split these bits of data into chunks. So every file gets split into chunks with overlapping windows. And here's the first one. So we can see some other ones. So the chunks gradually paginate through the documentation. Now I'm going to insert these docs into my MongoDB. So in this step here, I'm executing basically a classic PyMongo query with SuperDuperDB. So you'll see it looks a bit different than PyMongo, but under the hood, it's using the same functionality. And I'm wrapping the documents I'm inserting with our document wrapper. And I won't go too much into detail about what that is, but this is essentially allows us to add things like videos and images as well as standard MongoDB documents. So I've inserted my documentation into MongoDB, and you can see it here on my Atlas deployment. I now have a new collection which contains the documentation. Now I'm going to set up the vector search using SuperDuperDB. So Atlas provides this functionality to search through the vectors contained in your database with another vector. And SuperDuperDB allows you to essentially close the loop, going from the human readable input, so the questions you want to ask about your docs, through to connecting those into a vector, so transforming those into a vector and storing them in the database. So the important concepts for doing that are firstly model. So a model is like a wrapper in SuperDuperDB around some AI ecosystem, so open source or self-built AI model. So here is an example of a model. It's an OpenAI model, but this could equally be a PyTorch model or Transformers model. And you can see here, this model outputs vectors. So there's a long vector. So there are many ways to configure this. You can add pre-processing, post-processing, various things. So OpenAI is like one of the simplest ones to turn text into vectors, but there are many options there. So the next thing we need is a listener. So a listener is another layer up. It takes a model and deploys it on the database. So you've got this input model, and then you tell the listener which keys in your documents to look at in order to create vectors. And you also select from your collection which data you would like to act on. So you don't necessarily need to use all of the data. So now we have this listener, and now we have the components ready to create the vector search. So to create the vector search, I take this listener and give it a name. So under the hood, MongoDB is, SuperDuperDB is talking to MongoDB Atlas, telling it to set up and be ready for vectors coming from the model. And SuperDuperDB then stores the vectors in MongoDB Atlas. So we can see that here. So if I go to my collections, I can just refresh this page. I can see now the documents have this outputs field, which contains the vector computed by this model. So that was the name of the model on this key. So this input key. So that corresponds to the key in the main document. So now that's done, we can also see here on the search tab that we have a new index. So it's a vector search index, which was automatically activated by SuperDuperDB when it was configuring your your search functionality. So we can verify, the vectors are in there also on our side, so we can just collect a document and check that we have those outputs in there. And now we can actually test the search functionality. So the first step in creating a RAG app is to have search implemented, so that when you ask a question, the question is used to search for relevant documents to that question. So we can check that here. So what I've got here is a query which looks like a standard MongoDB query, but has this additional operator like. So we're chaining the like operator with the find operator. And in SuperDuperDB language, like is the operator to instruct the system to find the items which are like my query using vector search. So it's kind of an intuitive way of thinking about this. Find documents which are like this query. So this is the query. And then filter them. So I could also add a filter here. I could add a regex or something like that to restrict the range of the results. Okay, and now you see I've displayed these snippets. So I've asked something about vector search, vector index, sorry, and it's given me relevant bits of information here. Okay. So now on to the next step. We're going to create the model which is going to be used to talk to the database. So in this part, we're going to use the same type of thing as last time, with a model which was used to create vectors. There are other versions which you can chat with. And we have OpenAI chat models, but there are also models, open source models, such as Llama 2, which you could use on premise, so that you don't have concerns about data privacy in your organization. And just like adding a model previously, we add this chat model. So we can now see which models we have available. We have some from the video search example in the system, and now we also have an additional GPT model in there. And now we can ask the system some questions. So can you give me a code snippet to set up a vector index? So now, instead of performing a query, we are performing a prediction with the model, but which takes a query as context to the answer it's going to create. Exactly. So this is slightly different, but similar to the previous query that we created. So here we had something that looks a lot like a standard database query. We're executing this query object here. And the query is like more than a standard MongoDB query because it has this like operator in there. And the like operator takes care of converting the query to a vector. Now in this call here, instead of executing a query, we're predicting on a model which takes the results of a query as additional input in addition to your question, right? So we've asked this question to the model, can you give me this code snippet to set up a vector index? And we've passed the instruction to look for similar things to the question using a vector search in order to improve the answer. And so this is also, basically exactly what RAG is, but potentially even more general than that. So you could also put some cool filters in here, some business logic, which maybe is important to your organization. So maybe you want to filter to certain types of installations. Maybe you want to ask a question about a particular version of your API or version of your router that you might have at Cisco. And that will then condition the answer additionally to give you a more specific answer. And exactly, so here's a way to set up a vector index. This is actually a multimodal index. that's been set up here. But you'll see it's basically exactly what we've been talking about in this walkthrough. So at that point, I'm going to stop and receive questions.
Maybe while you collect your thoughts and to come up with different questions, there was one question how we compare to ChromaDB, and this is like one key topic I wanted to quickly raise, because with these specialized vector databases, something came up which is kind of additional to your current tech stack, and you need to introduce it just for the specific use case to perform vector search and then build RAG applications on top of that. And actually, it doesn't make sense, right? Because you already have your battle tested database. It's there and it's perfect. And now you basically have to again, duplicate your data, migrate it, and create all of that overhead. You have adoption costs, additional infrastructure, and there's just really, yeah.
It's what I call a waypoint database, Chroma. Yeah, it's another database, and you have to move your data to and from it because it doesn't scale very well. So it's just another box in your tech stack you got to deal with when you can use your existing database. And the question is kind of confusing anyway, because Chroma is a database and SuperDuperDB is not a database. So the question in the chat was, how does it compare? So the question would really be, how does Chroma compare to MongoDB? And the answer is there is no comparison. Chroma is still in very early development, and MongoDB is the third most popular database in the world. So
exactly. And with the
maybe I could also add something to that. I mean, so Chroma does have support for a few models in their offering. So they have a few default models which can be used to turn text into vectors, but they don't have first-class support for models, and they don't have this flexibility to be able to bring anything from the open source ecosystem to your database. So it's almost like by creating a system like that, you get the worst of both worlds. Whereas if you separate it and wrap your database with SuperDuperDB using a battle-tested MongoDB, then you're going to have a much more flexible and performant system.
Yep.
Timo and Duncan, if folks want to get started with SuperDuperDB on their own, what's the best way to get started?
I think these Jupyter notebooks are a great way to start, and then it's pretty much up for the use. It's up to the use case. So we would really be interested in hearing what you're trying to build. What is the problem statement? What is the data you're looking at? So after you've checked out the notebooks, of course, I would recommend to install it locally first, and then get going. And then just feel free really to reach out to us so we can help you out and kind of accelerate that onboarding.
Duncan and Timo, co-founders of SuperDuperDB, we really appreciate your time today and for dialing in all the way from Berlin. For our audience, there's two things I want to let you know before we wrap up the webinar. The first one, we're going to be sending a follow-up document to y'all. It will capture all the questions that were asked in the chat and the Q&A box. There's actually some questions that y'all couldn't see because it was just for the panelists. So we'll provide every response, and we'll share everything that Duncan and Timo displayed today, including a link to the SuperDuperDB repo. I'll also leave in our contact information as well in case y'all want to get in touch with them. And then secondly, we're also going to be sending out a form to give you the chance to register for our part 2, more of a hands-on workshop. So everything that we demoed today, we want to give access to you guys so that you have a chance to play around with vector search and with SuperDuperDB. The tentative date for this is November 16th. So just please be on the lookout for that. And last but not least, we all appreciate y'all for coming. We're going to keep this live demonstration series going through the holidays as well. So expect invites from us till the rest of the year. But again, want to thank y'all for your time and enjoy the rest of your week.
Yeah, thanks guys for having us. One final remark, I have to use it basically, guys. We would highly appreciate if you leave a star on the repository. You know, it's open source. Support the project, stay updated, and yeah, have a good rest of the day.
Thank you.
Bye.
Bye.